All right. Julian, what'd you get for the first one? 11. X equals 11. Raise your hand if you agree with Julian. Okay, not everybody's got a hand up. Someone who doesn't have a hand up, tell us what you got. Julie, what'd you get? 11 and negative 11. Raise your hand if you agree with Julie. Oh, traitors. Some of you are switching sides. All right, so what do we have to remember here? If we're going to take the square root of both sides to solve things, we have to remember to do both positive and negative, right? Is 11 a solution to our equation? Yes, but is it the only solution to our equation? No. If you are asked to evaluate a square root, okay, so just on paper somebody goes, hey, what's the square root of 64? Then you're only interested in the positive, what we call the principal root. So then you just say it's 8. But when it is part of solving, where we're actually trying to find solutions that are going to make our equation true, then we have to consider both the positive and the negative. And so a lot of times we'll just write that as plus or minus out in front, okay, to indicate that we've got both the positive and the negative answer. Okay? So we need more than just that. Okay? Now, when I take the square root of both sides in my next one, what do we get, Emma?
2 times the square root of 15.
Okay, and why did you say that's your answer?
There's another answer.
Oh, okay, my bad. Okay, so plus or minus, we need positive or negative, good. But why did you say 2 square root of 15? Why didn't you just say square root of 60?
I just factored out 4 from 60.
Okay, and why do we want to factor out the 4? What's special about 4 that we need to factor it out? It's a perfect square. Yeah. So this is an example of where we have to remember to simplify our radicals. If we end up with something inside of the square root that has a perfect square factor, we can't just leave it that way. Right? We have to simplify it. And for those of you who need a quick reminder, simplifying means if 60 can be broken down into 4 times 15, the square root of 60 is the same as the square root of 4 times 15, which can be split up as the square root of 4 times the square root of 15. Okay, that's the square root property that says if I am taking the square root of factors, I can take the square root of each factor separately. So when I take the square root of the 4, that's where just my 2 comes from. It's not inside the radical anymore. But the square root of 15 is not a perfect square, doesn't have any more perfect square factors in it, so I have to leave that inside the radical. Okay, and again, don't forget it's plus or minus. Okay, good. What do we need to do to solve this one, Sean? Okay, so what's that going to give me? X squared equals? Okay, and then what?
You basically do the same thing as the other question.
Okay, so what would you get for an answer?
3 radical
3 radical 3?
plus or minus.
Plus or minus, good. Don't forget that plus or minus there. Okay, so if we add the 12 over to get the x squared by itself, we end up with 27. When we take the square root of it, 27 has a perfect square factor of 9, so we have to simplify that to plus or minus 3 squared root of 3. Okay, morning. What happens in our fourth one? Anna?
I found no solution.
Why?
Because guys, if you move the 29 to the other side, it will be x squared equals negative 16, which is not possible for us.
Okay. Are you just observing or you some? You just gonna
I
watch?
just need to look at this book real quick.
That book real quick. Okay.
I'm observing the book.
Okay. All right. So, how many of you agree with Anna that this is not possible? No solution. All right. And if we were still in Algebra 1, I'd say, yes, you got it. But we're not anymore. We're now in Algebra 2. It's time to put our big boy pants on. Now we need to be able to deal with these kinds of issues. If I want to take this square root of both sides to get x by itself, when we were in Algebra 1 and we said we were only interested in real number solutions, we would say this wasn't possible because you can't take the square root of a negative and get a real number solution. But now we're interested in any solutions. And so we can take the square root of a negative if we broaden our boxes. So remember our boxes from a couple weeks ago? Okay, these are all the subsets of numbers that we have within the real numbers. So if I can take a square root and get a number that's like this, we're all good. But now we have to make our box a little bigger. So the blue box still represents the real numbers. But now we're adding on this other box out here that's in orange, and that represents the imaginary numbers. Okay? So imaginary numbers are those that are in this standard form of a plus bi. And b is not going to be equal to 0. So what's happening really is that in the blue box, these actually were all in the a plus bi form, but b was 0. Okay, so all we ended up with were just the a's, and the a's are the real number parts, and so this blue box represents all the real numbers, which is really just a plus bi when b is 0. But if b is not equal to 0, then that means we get this I piece in there. And when we have the I, we have what we call imaginary numbers. Okay? If we have just the I and the A is actually 0, then we have what we call a pure imaginary number. 3I, negative 2I. Okay? But if it's in this a plus bi form, then we have what's called an imaginary number, and the entire box, all of this together now, represents a set of numbers we call complex numbers. Okay? So, what does I actually represent? Anybody remember from Algebra 1? Julie? The root negative 1. Good. So it is not a variable. Okay, this letter I is not being used to represent something unknown. It is being used to represent something we do know, which is that it's the square root of negative 1. Okay, so we have to be careful that we're not trying to treat I like a variable. We're not trying to solve for it. We're not trying to figure out what it's supposed to be equal to. We know what it's equal to. Okay? So I is meant to be more of a representative symbol, not a variable. Okay? Now, if I square I, then what's that going to have to be equal to? A negative 1. Right? Because if I square this side, I would have to square this side. Well, squaring a square root cancels out. So I squared is going to have to be equal to a negative 1. What is an I cubed going to have to be equal to? What do you think? Yeah, or negative I. So we'd have this negative 1 from I squared, and if I multiplied each side by another I to get I cubed, then I'd have a negative I. And then I to the 4th is 1. So what then is I to the 5th equal to? The square root of negative 1. It just goes back to I. And the I to the 6th, negative 1, and I to the 7th, and I to the 8th, and I to the 9th, and it just keeps cycling through these 4 possible answers. Okay? So if I ask you something like, what is I to the 49th power? I don't know. It's actually really easy. Take your 49, divide it by 4, because that's how many terms we have here in this cycle that keeps repeating itself. So divide it by 4 and see how many times are we going through the cycle. So 4 goes in 12, gives me a 48, and then what's the remainder? 1. So that's how far we go beyond the cycle. So I've gone through cycle, 12 times. 48. 49. So I to the 49th is really just equal to I. Okay, kind of cool. So then, if I ask you to simplify something like the square root of that negative 16 that we had as an answer, what we're really doing then is saying, well, that's really the same as, actually, let's put that up just that. The square root of negative 1 times 16, which, as we just said, we can split up and say square root of negative 1, square root of 16. So now what's the square root of 16? 4. What's the square root of negative 1? I. So the square root of negative 16 becomes 4i. Remember that? Is that ringing some bells from Algebra 1? A little bit? Okay, so basically what happens is anytime you take the square root of a negative, you simplify the number part as you would anything else. So if it was a square root of negative 60, you would still do the 2 square root of 15, but then you'd have to have an I in there because of the negative. So if I had like the square root of a negative 60, we saw before that just the square root of 60 was 2 square root 15, right? But now in order to take the square root of the negative part, that becomes I. That's not in the radical anymore. When you transform that into I, you are taking it out of the radical sign. So it would be out there with 2. So you would say it's 2i square root of 15, because it was negative 60 rather than positive 60 that you were trying to take square root of. Questions?
So when you do like this, so it wouldn't be plus or minus 4i?
If it's part of doing an equation, yes. So if this was what we had gotten in that equation and we were trying to solve it, then yes, we would have to say plus or minus 4i is our answer. Yep, good. If it's just straight up, I'm asking you what's the square root of negative 60, you just say it's 2i square root of 15. That's just an evaluating task. But when it's part of solving, like this negative, or the square root of negative 16 was in that previous problem, then the plus or minus still has to be involved. Yep. Okay? Now, the nice thing is, even though I is not a variable, when we start doing operations with it, it acts like one. So everything we know about working with x's, in this case, if we were adding things together or subtracting things or multiplying or dividing or whatever, pretty much what we would expect to happen if it was a variable is what's going to happen. So for example, if I'm asking you to add these two complex numbers together, this first parenthesis is just representing an a plus bi complex number. The second parenthesis is just representing a second a plus bi complex number. Okay? Adding these together is simply a matter of combining like terms. So the real parts will get added to the real parts, and the imaginary parts will get added to the imaginary parts. So what is my answer going to be?
6 plus 3i.
It's not any more complicated than that. Okay? How about for subtraction? What am I going to end up with? Good. Just remember to distribute that negative to both the real and the imaginary part. Okay? So, what your gut tells you should work is what's going to work. Okay? The I is going to work just like an X would or a W would if it was a variable. We're just combining like terms. Same thing for multiplying. We can FOIL, we can distribute, just like we do with variables. So if I take negative 2i and I multiply it by 3 minus I, what am I going to get? Now, here's where the kicker comes with multiplying. We're usually asked to give answers that are in standard form. Is that a plus bi standard form? No. So how do I change that into a plus bi standard form? Julian?
You replace I squared with -1.
Exactly. So we're going to replace the I squared here with a -1. And then multiply that by the 2, which basically means I end up making this -2 in here. Right? So I'm going to cancel out the I squared and make the number the opposite of what it was, because I'm going to take that number and multiply by -1. So now, if I rewrite it, I'll have -2 minus 6i. Now does it fit a plus bi form? Yeah, so now I've got my standard form answer. Okay, so when you're multiplying, there's a real high likelihood you're going to get an I squared in there somewhere. You're going to need to replace that I squared with a -1 so that you can get the standard form answer they're asking for. Okay? Even if I'm taking a complex number to an exponent, how I do that is still the same. What do you think, Henry? What should we do with that? Exactly. So we're not going to do 16 plus 25i squared. Right? We're not going to fall into that trap because we're smart boys and girls now. We're going to either use the pattern of taking a binomial and squaring it, or we'll take 4 plus 5i times 4 plus 5i, we'll FOIL it out. Okay? All right. But here's the one that we really need to look at for today. And then we'll pick up with the rest of this next class and continue. How do you divide them? Anybody remember from Algebra 1? How do we divide these crazy complex number things? And end up with a standard form a plus bi answer? Well, what's kind of messing us up here is the fact that my denominator has this complex number in it. If I'm really going to get standard form answer, I don't want that complex number. So we're going to multiply by something that gets rid of the complex number for us. And that thing is called the complex conjugate. It is not the opposite. The opposite of that denominator would be a negative 3 minus 4i. Okay, it's not that. The 3 is staying the same. The only thing changing is the sign in between. So since I started with plus, I'm changing it to minus. And because I need to keep things equivalent, I have to multiply that on the top and the bottom. So I'm basically multiplying by a 1. Now, why is that helpful? Well, what happens when I now FOIL out the denominator? 3 times 3, 9. 3 times negative 4i.
It wouldn't matter because those two would cancel out.
Yeah, so my outsides and my insides are going to cancel because one's negative, one's positive. So I've basically set up a difference of squares kind of situation. So my middle terms cancel out, which just leaves me then with my lasts, which will be a negative 16i squared. But then what? Hang with me for just a second. Yeah, this is going to turn into negative 1, so I really end up with 9 plus 16, and that's going to be a 25. Boom. No more complex number.
Wouldn't it be 9 minus 16 because plus 16 is?
It was minus, right? Minus 16i squared.
You wrote the third one wrong. That's why I got confused. Because it's supposed to be minus 16i squared.
It was. Let me go back a few steps here. Right? That's what I wrote.
In the negative side, okay.
Okay? And then, let me do it in a different color. Because this is negative 1, I canceled it out and made that plus. Because now instead of subtracting 16, I'd be subtracting a negative 16, which means I'm adding 16. Okay? That's kind of the shortcut way of doing that. So that's why I'm getting 25 there. Okay? And then if we do a quick FOIL here, that's a 6, that's negative 8 with negative 3, so negative 11i, and then a plus 4i squared, so that's going to become negative 4. So we end up with 2 minus 11i. And then to get the true a plus bi form, you just say it's 2 over 25 for a, minus 11 over 25 for b, I. There's your standard form complex number answer. Okay? It is also described in your book. So I know that was a really fast description, but I want you to do this. It's in Canvas. And then there's a part about graphing an absolute value. I want you to look at the lesson and try it. And then if you have questions, come with questions for Monday. Okay? And then we'll continue from there. Thank you for hanging on for an extra minute. Hustle to your next class. Sorry about that. Okay, can you, leave it on the table there. I will grade it, and then I'll put it in your folder, so if you want to come pick it up before Monday, you can just come in sometime and get it out of your folder, okay?